Welcome to Code Crafting with Ashay, and today we are looking into an exciting video, and we are trying to solve a problem which is from strings. Okay, so the problem name is minimum number of steps to make two strings anagram. Okay, so let's read the problem statement and then we will see how to solve this problem. So this says that you are given two strings of same length s and t. In one step you can choose any character from t and replace it with any another character. Okay, so actually we need to return the minimum number of steps to make string t an anagram of s. Okay, so we need to make t an anagram of string s. Okay, so first of all, what is an anagram? It is nothing but actually a string that contains two strings that contains same characters, but the ordering may be different. Okay, the characters which means the count of characters should be same, but the ordering can be different. Okay, so this is the problem statement. So also let's take an example. What does the anagram means? So for example, let's say we have a string called data, okay, and another string as type. Okay, so we can see the length of both the strings is equal. Okay, so the length is same, that is 4 and 4. Okay, but if we see here, the count of character a is 2, d as 1 and t as 1, but here t has count 1, y has count 1, p and e both, all of them is having count 1. So definitely there is no matching of the frequency. Okay, so since the frequency is not matching, we can say that both are not anagrams of each other. Okay, let's take another example where the strings can be anagram. Okay, so let string s as anagram and string t as mangar. Okay, so these are the two strings. So let's check the count. A has having count 3, n is having count 1, g is having count 1, r is having count 1, and m is also having count 1. Okay, here m is having count 1, a has 3, g has. So similarly we can see that count is equal, therefore the two strings, this one and this one, are anagrams of each other. Okay, so now we understood. Okay, so what does, okay, let's talk about then the naive approach. What does the first approach which comes to your mind? How can we solve this problem? Okay, we need the minimum number of steps, actually minimum number of steps to make string t as anagram of s. We have to convert t to make it anagram of s. Okay, let's check how to do this. Okay, then first of all, one thing which is coming to my mind is that we need the count of every character from both the strings. Okay, so therefore we will be needing map. Okay, so we will be needing a map for s, string s, which will be containing the characters count for s, and another map for t, string t, which will be containing the character count for t. Okay, so let's check. Here a is having count 2 and b is having count 1. Here a is having count 1 and b is having count 2. Okay, so okay, these are the first, this is the first step we have done. Okay, in the naive approach. So how, one thing which is coming to my mind is that we will be going through the map of s. Okay, this map, we will be going through the map of s, and for each and every character we will check, actually we need to check that whether, like this character, whether the first, this character a is present in t or not, and if it is present, then we will also need to check that whether the count of that character in the t, whether equal to less than or equal to s dot count of that character. Is it so? Like here a is equal to 1, a is having count 1, and here it is 2. So of course there is one one character less, so we will be needing that character, right? So here in that case we will be incrementing the count from 0 to 1. Okay, we are nothing but checking whether that character is present in t or not, this map t or not, whether it is present in there or not. Okay, if it is present, then we are simply taking the difference of both. So this is the if condition. So in the if condition, what we are doing is here we will increment the count by the difference of both. So for example, this is let's give them a name. So this is s map and this is t map. Okay, so for suppose we are having the count, count. Okay, so in that case the s count we will take the difference. Okay, s count minus t count, and of course it will be count plus equal to, because we will be continuously adding into the count. And after getting through all those characters from the map of s, and finally from getting out of that map, we will finally having the result in our count variable. Okay, and then simply we will just return the count variable. Okay, so this will be the whole approach, naive approach or brute force approach. Okay, so now let's code it up, the brute force approach, and then we will look into the optimal approach. Okay, so let's take the unordered map. Okay, and then let's count the characters for each of the string. Okay, so for char ch in string s. Okay, and let okay, so we have count the characters in each of the string. Okay, so let's declare an step variable which will hold our answer. Okay, so int step, and let's initialize it with 0. Okay, so now we will loop through the map of s string, and we will check whether that character is actually present in the map of string t or not. If it is if it is not present, then definitely we will need to increase the count, and if it is minimum, if the count is minimum, then we will take the difference of that. Okay, so let's loop into the map, okay, of string s. Iterator in s frequency. Okay, so what is that char? Let's take the char as, so this is our character. Okay, let's take the count also. So s count, so s count will be dot second. Okay, and then int f count. Okay, f count will be what will be the f count? F count will be f frequency of the character ch, right? So this will be our f count. So now we will be looking, that if the character is not present in t, okay, or or otherwise, or the count is less in t. Okay, so this is the condition we are checking, whether the character is present in the t or not, or if whether the count is less in t, right? Then in that case, if t count, sorry, this should be t, let's take it t, right? So t count is less than, if it is equal, okay, let's say it's equal also, right? If it is less than equal to s count, well, in that case we will simply s count, take the difference, okay, t count, right? Let's take it as steps, make it as steps, okay? And finally we will be having our answer in the steps, total number of steps required, okay? So return steps, okay? So let's run it and let's check whether we are going in the right way or not, okay? So let's run it first. So let's run it, okay? Okay, we are missing here. Okay, let's run it again. Oh, sorry, here it should be f frequency, right? Let's give it t name, right? That should be t, and here also it should be t, right? So yeah, now it should run, right? Run it again. Yeah, it's running fine. Let's try to submit it. Yeah, so it is working, right? The code has been accepted. But now let's see the optimal approach also. Okay, so let's get back into it. Okay, so optimal approach. How can we go into the optimal approach? How can we improve our brute force approach? How we can improve it? So what we were doing actually. So for string s, we were taking a map, separate map. Okay, and for string t also, we were taking separate map. But we can do something better here. Okay, we can optimize here. How about we can take like an vector array, okay, a vector which will be having of size 26, which will be 0 to 25 actually, because there are only 26 characters, and we will loop through the string s, and for each character we will increment the count, okay, count of that character. Okay, so first of all we will loop through all the characters of s. Okay, we will increment the count as well. Okay, it will be 1. So in the step 1, so this is the step 1. Okay, we'll check the character count, and then in the step 2 we will loop through the string t, and we will decrement the count. Okay, so let's do it. Okay, so for p, in the same data structure, okay, we are just defined the vector of length 0 to 25, of length 26. Okay, the length is 26 because there are only 26 characters. So in the same data structure, now we are looping through string t, and we will be decrementing the count. Okay, because we need the same characters in both the strings. Okay, that's why. So for p, it will, since it was 0 in this data structure, it will be -1. Okay, and similarly for r, it will be -1. And for a is not there, right? So again it will be -1. And then for c, yeah, c is there here c is there, right? This is there, c. So the count will be 0. For t, let's say for t, again t is there, right? There, here it is. So the count will be 0. And I is not there, right? So the count will be -1. Again c is come, so the count becomes -1. And then e, the count becomes e is there, right? So the count becomes 2. So the count becomes 2. Here it is -1 and t is become 0. So in the step 3, this is the most important step 3. Here we will be having our correct answer, right? So let's see how. Okay, so let's see how. Total data structure, we have L is equal to 1, E here, this is the updated E, right? So E is equal to 2, then T is equal to 0. T is having 0. Okay, C is -1, O is 1, and D is also 1. So this is the data structure. Again we are also having this P is -1, okay, R is -1, and I is also -1. So other things are also there, but the most important thing, what is that? See, we have counted the characters in string S. We have also eliminated all those common characters which were present in T, right? Which were present in T. What does it mean? It simply means that if that character is present in both the strings, okay, if any character ch is present in both the strings, if it is present in both the strings, then what we need is the count of character from string T. If it is less than the count of character from string S, okay, then we will take that difference. That means if the count is greater than 0, then definitely that will be added to our answer. Why? Because those characters which are greater than 0 will be definitely should be those are the only characters which we need to be updated, which we have to update. So L is equal to 1, E is equal to 2, right? So O is equal to 1, D is equal to 1. So these are the characters which have unique property, uniqueness. So these are the unique characters which are present in string S. Therefore this will hold our answer. The count of these unique characters which are present in S, which are present in string S, but not present in string T, which are not present in string T, right? Present in S but not present in T. That's why they will be included in our answer. So total steps will be 1 plus 2 plus 1 plus 1, 1 2 1 1, right? So it will be 5. So therefore for this example the answer will be 5. Okay, so let's quickly see another example also, so for better understanding. So the algorithm must be clear into your head, and now let's simply take our answer, our algorithm, and just dry run it. Okay, so let's start. So this is our data structure. It is nothing but a vector, but I am taking it as a just to make it understand, make it explain. Okay, so this is our data structure, and let's let's loop into the string s and keep the count of all the characters. So a have count 2, m has count 1, and n has count 1. Okay, so this is the string s. Okay, and now let's take string t. So let's loop into it. A, does a is present? Yes, it is present, so we will reduce the count, so 2 becomes 1. Then j is present? Not present, so j is equal to -1. Okay, because it was 0, because earlier it was 0, so it will become -1, right? Again we are coming to a is present, right? So decrement the count, so a becomes 0. Okay, now again incrementing, coming to y is present? No, not present, so 0 becomes -1, right? -1. So now simply at last step, in the last step, just loop through the data structure. Okay, loop through the data structure and simply check whether the character is having count greater than 0 or not. If that character is having count greater than 0, that means simply that character is unique, which is present in only s and not present in t. Correct? Those are the unique characters which are only present in s but are not present in t. Therefore those will be included in our answer. So therefore total steps will be equal to 1 plus 1, that is equal to 2. So this will be our answer for this example. Okay, so let's code it up and we'll try to submit it. Okay, so let's start. Okay, so let's define a vector. And now let's loop through the strings and keep the count, increment the count for s and decrement the count for t if it is okay. So frequency of character minus, we have to subtract the character a, so that we'll get the exact number for that. Okay, so we'll be incrementing it. For character ch in string t, frequency of ch minus character a, and we will be decrementing it. Okay, so common strings will be eliminated, as simple as that. Common strings will be eliminated. So steps will hold our answer, and finally we will loop through the okay. So simply just we'll check whether the count is greater than 0 or not. If it is greater than 0, that means those are the unique characters present only in string s. So we will be incrementing our steps. Okay, and then finally at last just we will return our steps. Okay, let's try to run this. Okay, let's try to submit it. Yeah, so it beats 94.43%. Okay, so yeah, it is taking lesser time, and this solution is optimal solution, right? We have taken just constant space, and the time complexity is of course order of n, because we are looping through the strings. Okay, so here it will be big O of n, where n is the size of length of the string. Okay, so that's all guys for this video, and if you like this video, please do tap the like button, and also please don't forget to comment. And thank you so much guys for watching this video, and see you in the next video. Thank you.